N- Namaste, myself Jevin Shivi Saxena, Faculty of Physiotherapy and Diagnostic, and my discipline is Medical Laboratory Technology from Jyoti Vidyapeeth Women's University, Jaipur. So, welcome in Digital Version 2.0. So, my today topic is centrifuge. So, firstly, start my topic, uh, a centrifuge definition. So, let's start. A centrifuge is a device used to separate component of a mixture on the basis of their size, density, and viscosity of the medium and the rotor speed. The centrifuge is commonly used in laboratories for the separation of biological molecules from a crude extract. In a centrifuge, the sample is kept in a rotor that is rotated about a fixed point, that means axis, resulting in strong force perpendicular uh, to the axis. There are different type of centrifuges used for the separation of different molecules, but they all work on the principle of sedimentation. Okay. Next, centrifugation definition. Centrifugation is the technique of separating component where the centrifugal force acceleration causes the denser molecules to move toward the periphery, while the less dense particle move the center. The process of centrifugation relies on the perpendicular force created when a sample is rotated about a fixed point. The rate of centrifugation is dependent on the size and density of the particular particles present in the solution. So the images, sorry, relative centrifugal force, that means RCF. So relative centrifugal force is the measure of the strength of rotor of different type and size. This is the force exerted on the content of the rotors as a result of the rotation. RCF is the perpendicular force acting on the sample that is always related to the gravity of the earth, and the RCF of the different centrifuges can be used for the compression of rotors, allowing the selection of the best centrifuge for a particular function. The formula of the calculate the relative centrifugal force, that means RCF, can be written as RCF bracket G force is equal to 1.118 into 10 to the power minus 5 into R into um, RPM and RPM square, where R is the radius of the rotors in centimeter, and RPM is the speed of the rotor is rotation per minute. So centrifuge rotors. Rotors in centrifuge are the motor device and that house the tubes with the sample. Centrifuge rotors are designed to generate rotation speed that can bring about the separation of component in a sample. There are three main types of rotors used in a centrifuge, which are: first, fixed angle rotor. These rotor hold the sample tube at an angle of 45 degree in relation to the axis of the rotor. And in this type of rotor, the particle strike the opposite side of the tube, where the particle finally slide down and are collected at the bottom. These are faster than other types of rotors, as the path length of the tube increases. However, as the direction of the force is different from the position of the tube, some particles might remain at the side of the tube. And second, swimming bucket rotors and horizontal rotors. So swimming bucket rotors hold the uh, tubes at the angle of 90 degree as a rotor swing as the process is started. In this rotor, the tubes are suspended in the racks that allow the tubes to be moved enough to acquire the horizontal position. In this type of rotors, the particles are present along the direction or the path of the force that allow the particles to be moved uh, away from the rotor toward the bottom of the tubes. Because the tubes remain horizontal and superintendent remains as a flat surface allowing the deposited particles to be separated from the superintendent. And third, vertical rotors. Vertical rotor provide the shortest path length, fastest run time, and the highest resolution of all the rotors. The vertical rotors, the tube are vertical during the operation of the centrifuge. The yield of the rotor is not as ideal as the position of the tube does not align with the direction of the centrifugal force. As a result, instead of setting down, so particles tend zero separate spread toward the outer wall of the tubes. These are commonly used as isobaric and density gradient centrifugation. Okay, so types of centrifuge rotors, types of centrifuges. First, Banktop centrifuge. So images this this is a Banktop centrifuge. Okay, so Banktop centrifuge is a compact centrifuge and that is commonly used in clinical and research laboratory. Okay, and it is driven by an electric motor where the tubes are rotated about a fixed axis, resulting in force perpendicular to the tubes. Because these are very compact, they are useful is in smaller laboratories with a smaller space, and different variation of Banktop centrifuges are available in the market for various purposes. Banktop uh, centrifuge has a rotor with rack for the sample tubes and a lid that closes the working unit of the centrifuge. Okay. Second, continuous flow centrifuge. Continuous flow centrifuge is a rapid centrifuge that allows the centrifugation of large volume of sample without affecting the sedimentation rates. This type of centrifuge allows the separation of a large volume of samples at high centrifugal force, thus removing and tedious part of emptying and filling that the tube with each cycle. They have a shorter path length which facilitate the process of pelleting out the solid part out of the superintendent, thus maintaining the speed of the process. They also have larger capacities, which save time as the sample does not have to be loaded and unloaded over and over again like in traditional centrifuges. Up to 1 liter of sample can be centrifuged by this centrifuge at a time period of 4 hours or less. Okay. And third, gas centrifuge. Wait a minute. This is gas centrifuge. Okay. So a gas centrifuge is a centrifuge expectancy used for the separation of gases based on on your isotopes. Okay. This centrifuge is based on the same principle of a centrifugal force uh, as all other centrifuges, where the molecules are separated on the basis of their masses. This centrifuge is used mainly for the extraction and the separation of uranium minus 235 and uranium minus 238. The gas centrifuge work on uh, design of the continuous flow of gas in and out of the centrifuge, unlike other centrifuges working on batch process. These centrifuges are arranged in cascade so that the gases are separated into two units based on their isotopes and then are passed on to the next centrifuge for further processing. Gas centrifuges have replaced other gaseous diffusion method as they provide a yield of higher concentration of the gases than the previous techniques. Okay, hematocrit centrifuge. So this image of hematocrit centrifuge. This is a hematocrit centrifuge. So hematocrit centrifuges are specialized centrifuges used for the determination of volume fraction of erythrocytes in a given blood sample. The centrifuges provide hematocrit value that can be used for testing in biochemistry, immunity, blood tests, and other general clinical tests. Hematocrit centrifuge may be used to help diagnose blood loss, polycythemia, and elevation of the erythrocyte count to above normal level, anemia, bone marrow failure, leukemia, and multiple myeloma. The microhematograph centrifuge quickly attain a speed of 11,000 RPM and RCFs of up to 15,000 G to spine tube sample. The component of a hematograph centrifuge are similar to that of the Banktop centrifuge, but this centrifuge is specialized for the use of blood samples. Okay. Next, high speed centrifuge. So there's this is high speed centrifuge. Okay, so high speed centrifuge, as the name suggests, is the centrifuge that can be operated and somewhat larger speed. Okay, so the speed of the high speed centrifuge can range from 15,000 to 30,000 rpm. The high speed centrifuge is commonly used in more uh, um, sophisticated laboratories with the biochemical applications and require a high speed of operations. High speed centrifuges are provided with a system for controlling the speed and temperature of the process, which is necessary for the analysis of sensitive biological molecules. The high speed centrifuges come with different adapters to accommodate the sample tube of various size and volume. All three types of rotors can be used for the centrifugation process in these centrifuges. Okay. Next, low speed centrifuges. Low speed centrifuges are the traditional centrifuges that are commonly used in laboratories for the routine separation of particles. These centrifuges operate at the maximum speed of 4,000 to 5,000 rpm. These are usually operated under room temperature as they are not provided with a system for controlling the speed or temperature of the operation. Swimming bucket and fixed angle type of rotor can be used in these centrifuges, and these are easy and compact centrifuges that are ideal for the analysis of blood samples and other biological samples. The low speed centrifuges work on the same principle as all other centrifuges, but the application is limited to the separation of simple solution. Okay. Centrifuges. So microcentrifuges are the centrifuges used for the separation of samples with smaller volumes ranging from zero point 0.5 to 2 ml. Microcentrifuges are usually operated at a speed of about 12,000 to 13,000 rpm. This is used for the molecular separation of cell organelles like nuclei and DNA and phenol extraction. Microcentrifuges, also termed microfuses, used sample tube that are smaller in size when compared to the standard test tube used in larger centrifuges. Some microcentrifuges come with adapters that facilitates and the use of larger tube along with the smaller one. Microcentrifuges with temperature control and are available for the operation of temperature sensitive sample. Next, refrigerated centrifuge. Refrigerated centrifuges are the centrifuges that are provide the temperature control ranging from minus 20 degrees Celsius to minus 30 degrees Celsius. A different variation of centrifuge is available that has a system of temperature control which is essential for various process requiring lower temperatures. So refrigerated centrifuges have a temperature control unit in addition to the rotor and rack for the sample tubes. These centrifuges provide the RCF of up to 60,000 Xg that is ideal for the separation of various biological molecules. These are typically used for collecting substances that separate rapidly, like yeast cells, chloroplasts, and erythrocytes. The chamber of refrigerated centrifuge is sealed off from the outside to meet the conditions of the operation. Next, ultra centrifuge. Um, Ultracentrifuges are the centrifuges that operate at extremely high speed that allow the separation of much smaller molecules like ribosomes, proteins, and viruses. It is the most sophisticated type of centrifuge and that allow the separations of molecules that cannot be separated with other centrifuges. So refrigeration system are present in such centrifuges that help to balance the heat produced due to the intense spinning. The speed of these centrifuges can reach as high as 15 1 lakh 15,000 RPM. It can be used for both preparing and analytical works. And ultracentrifuges can separate molecules in large batches and in a continuous flow system. In addition to separation, ultracentrifuges can also be used for the determination of properties of macromolecules like the size, shape, and density. Next, vacuum centrifuge or concentrator. So vacuum centrifuge utilize centrifugal force, vacuum, and heat to speed up to laboratories evaporation of samples. These centrifuges are capable of processing a large number of samples, so up to 148 sample at a time. Okay, so this type of centrifuge is used in chemical and biological laboratories for the effective evaporation of solvent present in sample, thus concentrating the sample. These are commonly used in high throughput laboratories for samples that might have a large number of solvents. So a rotatory evaporator is used to remove the unnecessary solvent and eliminate solvent bumping. The centrifuge works by lowering the pressure of the chamber, which also decreases the boiling point of the sample. This causes the solvent to be evaporate, concentrating the particles to be separated. So, types of centrifugation. First, analytical centrifugation. Analytical centrifugation is a separation method where the particles in a sample are separated on the basis of their density and the centrifugal force they experience. Analytical ultracentrifugation is a versatile and robust method for the quantitative analysis of macromolecules in solution. So principle of analytical centrifugation. Analytical centrifugation is based on the principle that particles that are denser than others settle down faster. Similarly, the larger molecules move more quickly in the centrifugal force than the smaller ones. Analytical ultracentrifugation for the determination of the relative molecular mass of the macro molecules can be performed by a sedimentation velocity approaches of or sedimentation equilibrium methodology. The hydrodynamic properties of macromolecules are described by their sedimentation coefficient, and they can be determined from the rate that a concentration boundary of the particular biomolecules move the uh, gravitational field. The sedimentation coefficient can be used to characterize uh, changes in the size and shape of macromolecules with changing experimental conditions. Three optical systems are available for the analytical ultracentrifuge that permit precise and selective observation of sedimentation in real time. Step for analytical centrifugation. Small sample size 20 to 120 mm³ are taken in analytical cells to be placed inside the ultracentrifuge. The ultracentrifuge is then operated so that the centrifugal force causes a migration of the randomly distributed molecules through the solvent radially outward from the center of rotation. And the distance of the molecules from the center of determined through the Sinus optical system. So uses of analytical centrifuges. Analytical centrifuges can be used for the determination of the purity of macromolecules, and can also be used for the examination of changes in the molecular mass of supramolecule complexes. Besides, it allow the determination of the relative molecular mass of solute in their native state. Second, gradient centrifugation. So density gradient centrifugation as the separation of molecules, where the separation is based on the density of molecules as they pass through a density gradient under a centrifugal force. Principle of density gradient centrifugation. Density gradient centrifugation is based on the principle that molecules settle down under a centrifugal force until they reach a medium with the density the same as theirs. This case, a medium with a density gradient is employed, which either has a decreased density or increasing density. So molecules is a sample move to a medium as the samples is rotated, creating a centrifugal force. The more dense molecules being to move toward the bottom as they move through the density gradient. The molecules then become suspended at a point in which the density of the particles equals to surrounding medium. In this way, molecules with different densities are separated at different layers, which can be then be recovered by various processes. So uses of density gradient centrifugation. So density gradient centrifugation can be applied for the purification of a large volume of biomolecules, and in it can even be used for purification of different virus, which aids their further studies. These techniques can be used both as a separation techniques and a technique for the determination of densities of various particles. Okay, and third, differential centrifugation. Differential centrifugation is a type of centrifugation process in which components are separately down of settle down a centrifuge tube by applying a series of increasing centrifugal force. The principle of differential centrifugation. Centrifugation is based upon the difference in the sedimentation rate of biological particles of different size and density. As the increasing centrifugal force is applied, initial sedimentation of the larger molecule take place. Further particles settle down depending upon the speed and the time of individual centrifugation step, and the density and relative size of the particles. The largest class of particles form a pellet on the bottom of the centrifuge tube, leaving a smaller size structure within the superintendent. Thus, larger molecules sediment quickly and at lower centrifugal force, whereas the smaller molecules take longer time and higher force. In the case of particles that are less dense than the medium, the particles will float instant offsetting. Uses of differential centrifugation. So differential centrifugation is commonly used for the separation of cell organelles and membrane found in the cell, and it can also be used for low resolution separation of the nucleus. And as the technique separates particles based on their size, this can be used for the purification of extract containing larger size impurities. Fourth, isopanic centrifugation. So isopanic centrifugation is a type of centrifugation where is particle in a sample are separated on the basis of their densities as centrifugal force is applied to the sample. So principle of isopanic centrifugation. So isopanic centrifugation is also termed the equilibrium centrifugation as the separation of particles taken place slowly on the basis of their densities and not on their size. The particle move toward the bottom and the movement is based on the size of the particles and the flow cases once the density of the particle become equal to the density of the surrounding medium and the density is the gradient increase as we move down the tube toward the bottom. As a result, the particles with higher densities settle down at the bottom, followed by less dense particles that form bands above the denser particles. It is considered as a true aquarium aquarium as this depends directly on the buoyant densities and not the size of the particles. So uses of isopanic centrifugation. Isopanic centrifugation can be applied for the purification of large volume of biomolecules, and this technique can be used as a technique for the determination of densities of various particles. So this session is completed, and any query, mention comments box. Thank you so much. Namaste.